as you should be able to compile. So there's not much specific technique or skills are required to do your project and to do the exercise platform. But basically, most of the modern program languages are based on the C and C++. So if you are familiar with any program language, it doesn't take a time to catch up the C language. But to practice the system code, I ask the student to use the C language for your the project A. First, we are going to start with the process creation. To process creation, we are going to use which is system code. So fork. So we are going to use a fork system code. A fork will share the data section, which means the same instruction is just a clone of the parent. So the process can be created by only parent process. Okay, parent and children relationship. So that can be used until the wait code is issued. We are going to use the first fork command, the system code. So this is the algorithm that we are going to implement. First, start the program, C program, using the main function, like the main, the classify in your Java language or other C++ language. The main function will be called the first time when we start C programming. Okay, then we are going to issue the fork out the return code of the output of the fork. The function system code is the process ID. So we will see the process ID. So using the fork command, I can declare section. So we are going to define the integer value that can receive the output of the fork, the system code. Okay? In case PID is 0 and print error, because PID 0 is for the error, that means error. If you want the details of such output and option, you can always check what? Man page. So man, the fork, then you will see a lot of the information. Or you can check the manual from the internet or the Debian OS. So then you will be able to use the fork. Otherwise, we can PID equal then the command, okay? Then otherwise the parent process wait for the child process. That is the normal thing. Okay? So included is similar as a package, but the package in the Java or the other object-oriented language is the compiled code. But this include means that it's a structure. Okay? Header information on the structure of the. So to use the printf, so we need the standard input and output, stdioh and the stdlibh. Sometimes you can see the this symbol bracket, or sometimes the different one. This one is as long as it's in the library path, so you can get the header file information. Then the main function is a void, so this function will be executed. So we are going to define the integer variable ID that will receive the output of the fork. So fork command, just simple. So fork, then the copy, and the parent current processor, this one. So if less than that, it's an error. So we can use the standard output as a printf function. So printf. So you will see the little bit example about the printf. If you want to know how to use a printf, you can use the man page also. Okay. Then if the ID is 0, so the child processor is created. And if that is not 0, which means it's currently is a parent processor, because we have two processes. So even child processor is the same as this one. Okay. So if this one is the process, so 111, then fork, copy that, there might be, okay, output that later we will see. So there will be two processes, child and parent process. If that is once the fork is issued, that is the output is 0, that is the child process, and if not, that is the parent process. So two processes will be running concurrently. So we will see the two output of this one. So why don't you open your editor, VI editor or the gedit, anything, okay? Why don't you open it and type as it is. Do not try to copy and paste. Copy and paste usually give the error. So why don't you type? If you already type and practice, why don't you run? So how can we compile? We are going to use CC and GCC. So GCC is a GNU. It's the open source. The compiler C, so either of them is fine, almost the same functionality. So sometimes the CC compiler is not free, depending on the operating system. However, GCC is the free software, so you can use either of them. And if you do not specify then .c file, you can create this file with the .c file. So it can be the create process.c or the tester.c. It doesn't matter. Okay, then you can give the C, then if you compile without any option, the output executable file is always a.out file. So you will see, if you type this one, then ls, you will see a.out file. This is your output file. If you want to specify the name of your output file, compile -o option. Then you can specify the output file, the name. So for example, this is the test.c file, test.c file compiled, and so ABC. So output will be the ABC executable file. We can later execute it. Why don't you type first, then be ready for compile.
Professor, where do we find the program?
In the virtual machine, why don't you type in your project description, you can see the source code. So why don't you, the file name, why don't we have the common file name? That is pc.c file, then why don't you edit the pc.c file, type the program source code in your project description. Right now I cannot control my So this is how to compile. You can use either GCC or the CC. So let me use the GCC. So in case, just type. So my file name is PC. So extension is always .c. So then if there is no error, it will be like that. Then there is a file, the a.out. So a.out is the output. If you wanna run the a.out, because currently the current location, current directory is not on your path, so you cannot execute that directly. Instead, as you have done in the shells programming, /a.out. So if you type the /a.out, the first parent process, there are two processes. So parent process, so prenoun is me. Then child process is created and child process, the prenoun. You have one program, but it's copied. When you create the child processes, there are two. It's exactly same, the program after fork. So this one is from your parent process, this one is from your child process. If you can see two of that, Sometimes it can be changing the order. It depends on how the operating system schedule, but mostly the parent will be displayed first. If you want to specify your executable file when you compile, like the gcc -o and pc.c, so ABC, okay? Here gcc is there's a gcc. So parameter is changed. Your output file ABC, then PC.C. Okay. Source file name is the second, and after -o option is the executable file name. So let me see. So ABC is here. So we can execute the ABC. Then output is the same as this one. The parent process, then child process. Yes.
So does it matter what version?
Version of what?
Of the terminal. Of that terminal.
The VR?
On the compiler.
Compiler?
Because it's telling me telling my C when I run it, it's telling my C to change the return temp.
Maybe, but mostly it's a general the source code. So what if you compile? So where did you? Warning is okay. Okay. Yeah, warning is okay. So it's not type comparable at the time. Because of that, you may get the error. Like if you assign the integer value to the double, then it may be the warning, but there is no problem to execute.
Okay.
Yeah, it depends on sometimes on the compiler.
Yeah.
Yes, but
the reason why we are doing the /ABC is the current directory is not on your path, which means you cannot execute the file on your current directory. So one dot means it's a current. Under the current directory, you are going to execute ABC. If your current directory is on your path environment, you don't have to. So next one is the select command. Okay, so we don't know whether this is done or whether it's quickly moved. So we are going to include the select. So it's basically the same, but slightly change it. So you can see first create the process. So instead of ID before, it's up to you. So you can use a PID or not. So we will check the output of PID. PID means it's a child process. It's created. So child process ID. This is the one of the popular syntax to use the printf function to include the integer variable inside your string. Okay, %d is the first, the comma, then the integer variable. So instead of %d will be replaced by the getPID function. So getPID is a function to get the current process ID. Process ID of this process. Okay, getPID function is process ID of this process. So you can see which one is which. The previous program, you don't know which one is which exactly. Just display child process, parent process. Then we can see. Then we'd like to know which one is the parent process. So parent process ID can be, it's the same idea, but get PPID function. So get PPID function, return parent process ID. Okay, then we can see what is the current process ID and what is the parent process ID, and sleep 5 seconds. It's the wait, similar as the wait function. I think the wait code in the Java is just wait 5 seconds, and after 5 seconds, the child process ID is what, and the process ID is what. So we will see the same value. We expect the same value because this is a child process. And for in case of parent processor, as we have seen before, the parent process, child process is exactly same code because they are sharing the data section. It's the same instruction. So it's the same code, but it will go to the here because it's the PID is different. PID has its own number. That probably the get PID, output of the get PID of the child process. Get PID of the child process. So it's a parent process. We will see the parent process ID and is a parent. So there the parent process. Okay. So because of the sleep 10, this part will be executed 5 seconds later. Right? That's what we want. So first, I'd like to demonstrate. So where is it? Oops. Cannot move. Because of the different resolution, can I use mouse? So I already added the file. It's a sleep.c file. So I can compile using gcc sleep.c. Then output is a.out always without the minus o option. So I can run a.out. So no, I actually explained the next one, right?
Yeah, you skipped the-
Sleep PID, third one. I skipped the second one. Okay, so sleep command. This is a sleep command. Okay. In the sleep command, I think the sleep command and the next one sleep with the get PID is almost the same because I already explained the sleep with the get PID. So sleep with fork command create the process with the sleep command. So it's just basically same as the previous one, but it will display the sleep. After sleep we can display and this one, which means the child process will be displayed this printf later. Okay, that's what we expect. Then next one, I already explained the sleep with the get PID. We will see the process ID. So I'm going to execute both of them. So first, this is the a.out of the sleep without. So you can see first the parent process, couple of seconds later, child process. Okay, it's working well. The second one. Third one, so sleep PPID, I need to compile gcc sleep PID, that's it, okay, then a.out. So you can see the first child process ID is the 2067, and its parent ID is 2066. Then child process is the same because it's just after 5 seconds later and still same. Okay, then parent process is 2066, right? It's the parent I think that I displayed. The current process is 2066 is the parent ID is 1980, which means 1980 is my shell. Okay, dash shell. Okay, I execute the a.out file. A.out itself is 2066. Okay, then this one issue the fork system call to create the child process that is the 2067. Okay, that is the overall how it works. So the main part of the creating process is you need to understand what happens when you create the process using the fork. Okay, it's exactly copy, and there are two the copies of the same instruction. Okay, but their PID and PPID are the different. That's the main thing. Okay, so why don't you execute and try to get the same result.
Because you didn't specify
You can see when you type the PS, it's a process list created by me. Okay, so I'm using bash shell. Bash shell process ID is 1980. 1980 is the parent of your a.out file. Then you can understand the structure of creating process. The bash shell is this is the bash shell. So 1980. Then I type. So this bash shell create the a.out file. How can create? How can execute? Execution means first you issue the fork. Okay? So first when you execute this one, fork, because of fork is the same as bash shell. Then we will see later using the exec, the system code, you can assign the specific instruction, programming code. Okay? So in your project A, you are going to do the exactly same thing, but a little bit more massages and polish it and add the function. So this is how it works in any program, any operating system. So that is the reason I try to use the little bit low level the programming. Actually, C is not low level, but comparing to object-oriented programming. But clearly we can understand how process can be created. But if we are using the Java crate or the thread, so not easy to understand such a mechanism. So if you are in behind, you can skip the number 2, then go to the number 3 select command using get PID because it's basically
This will
same.
help you with the project, right?
Yeah, definitely. So it's a kind of skeleton.
Okay.
Your project is to create developing such a shell program. How shell is working? Fork. Then during the exec, during the exec, you can input the input command that you typed. Okay.
Professor,
Yes.
have you made up your mind about undergraduate project? Have you made up your mind about undergraduate project?
Project B is for the optional for the undergraduate student. I probably announce. Then we'll get the extra point if you want to do something. Okay. One. So wait comment. Okay. So let's are going to use the same header file, and the integer is assigned as 10. In the main function, we create the process using the fork. Okay, in case this is the successfully created the child process, their initial value is I. That's probably the 10. Then increase the value. That increase the value will be 11. Okay, then child terminated. Then wait is the parent process. This is the else means it's the parent process, and it's just wait. Wait means because wait call means I'd like to hear the child response until terminated. So it's going to be the sleep, kind of sleep until this child process is terminated. Then display value of parent process is it what will be the value, expected value of this one? Is it 10 or 11? Sorry, 20. 10 or 20? This is a 10. After add up the 10 one, it's a 20. What about this one?
10.
It's a 10 because parent processor has its own local variable. Okay. So let's after you editing and compile, I already create the wait.c file. The wait.c file. Okay. Then compile using GCC or CC. Then 8.out. So you can see here. So first, initial value is 10 plus 10 is going to be 20. Then child process is terminated. Then followed by the parent process. Why? Parent process is waiting for the signal from child process. That is the wait. Okay. So in your program, so you can always wait until the command is executed. Then once it's finalized, then show the next event. So this is a 10 as we expected. Okay? This I and this I are different. This I is for child process and this I is for the parent process. What if child process fork again? Is it possible? Yes, it's possible. Always. It's a tree. The mechanism, parent process create the child process can create a fork. Then at that time you can imagine how many processes will be created. So that is the very popular question in operating system. You can see some example from the exercise. Then if you want, you can code by yourself and test what is the how many processes will be created and so on. Okay, that is the wait system call. Why don't you try to type and compile and run it. Also, I asked the GA. GA will give you the several reference sites regarding to the C programming. Also, those who want to learn a little bit more the C programming, I'd like to give the couple of the reference textbook. Most of them can be found online, so you don't have to purchase. Different. The instruction. So, using the exe command, we first fork, then we'd like to execute the ls command. Okay, you don't have to type the whole instruction. Just the instruction of this command, existing executable file, will be copied. Okay, to the where data section of the child process. The after fork actually copy the process but share the data section instruction. So because of that, it will execute the exactly same. But they have the their own stack area, temporary space, because of that value is not the same. Okay? So, however, exec will copy the other instruction to the child process, which means it's entirely, not entire anyway, it's just different. It will be different process. So, in our case, we will copy the ls command. So, this is the source code. We need to include one more, the header. It's a UNISTD. Okay? I don't know exactly what it stands for, but that's for the exec. So, just like the previous one, fork, okay, fail. Then, otherwise, it's 0 means it's successfully fork, but it's the same as the previous the parent. So we are going to use the exec LP. There are different versions of exec. It's called the exec family. Okay, so you can check your manual page, or if you type the exec, the system code, the Google, you will see the summary of that. So you can use one of them. We are going to use the LP as the input as the command. Okay, so bin ls, so ls will be the exec, which means in your data section of a child process will be ls instruction will be copied. Okay, then wait. This is the weight of what? S, okay? Which means it's a parent. Parent will be wait until when? This instruction is completed. ls command is complete. Then inform to the parent process, then child is completed. Okay? Then after you edit the file, by the way, if you download the old one, you do not have this source code, why don't you go to the canvas? If you can find the number 5 exec command, so why don't you go to the canvas, why don't you download the recent, latest version of the project description. Then you can see the file. So, file name is create PS. So, first, compile. So first, you need to check where is the ls command using which command, which the ls, which means where is the ls command. So we are going to exec this command /bin/the ls. So if you are using different operating system, different virtual machine, or different one, please check first where is your ls command. Okay, so it's already compiled. A.out. So, which means when I type the ls is this one, right? So it's exactly same output. Exactly same output as this. Then, when it's completed, the inform to the parent process who are waiting for response of child process. That is wait system code, then it's completed. This is actually basic kind of skeleton of your project A. In the project A, you can add a little bit more. So, for example, I'd like to change it. How can you get the input? Input is you can type as an argument. Okay? In C program, definitely it's ARG. ARG and array, and ARGV is the number of arguments. You can use the argument. So, for example, if we want to change it, so PS. At this time, you can see one more is different from the previous one. A.out. A.out is currently running, right? It's your program. So that is a reason A.out will be displayed here. So you can change that part in your project A. Okay, why don't you try? my case. So sometimes you cannot see the prompt. That's the only your shell program. Your program is completed, but your shell does not display this one. Everything is fine, so don't worry.
So this lab, this steps will help you with the project.
Oh yes,
Oh, yeah.
definitely. It's a kind of a skeleton program of the project. Need more decoration and input and output. Okay, and there's another part, second part, to select the.
That's also the possible.
Using the same idea, you can do that. So you can first display the executable file only, okay, with the 1, 2, 3, okay, or the option. Then the user can select that number and execute it.
Oh,
That's it.
really?
Yes. Okay. So I'd like to wrap up today's exercise lab. So those who want to do the more practice, why don't you stay here? GA, 2 GAs will help for the problem. Otherwise, we will see on Monday next week. Before you leave, why don't you submit your the homework to me or the GA? Okay.
Wait, so the homework's